Good morning, everyone. Welcome to all of you. I'm Kumar Ravi, and I welcome to all my students in the session of SSC CGL, CHSL, CPO, and UPSC CDL General Science MCQs. Okay, so friends, as we have already discussed that at the early morning at 10 a.m. We discussed the MCQs on physics, and at 2 p.m. we teach the general physics theory portion for the examination. Okay, so please do like this session and share among all your friends so that your friends also can also get the benefit of these classes. Okay, if you have not subscribed this channel, then please do subscribe this channel and press the bell icon button for the continuous update on our for our videos. Okay, so guys, today we are with the new questions, and I hope that you are watching these sessions with full energy and full concentration. Please welcome all of you again. Okay, so I think am I audible to all of you? Rajkumar Gupta, Jai Hind and good morning. Monica, good morning. Suresh, good morning. Yes, guys, do like this session among all your friends. Yeah. So today we will discuss some questions of general physics, and then we will discuss the concepts behind the questions also. Okay, so just pick a notebook and a pen and note down all these questions on a notebook. I'm sure that you will get these questions in any of your exam, because these questions these questions are very important and have been already asked in different examinations. Okay, so question number 1. See the question and please answer them in your comment box. Okay, guys, please do like this session and share among all your friends. Okay, so question number 1. A man presses more weight on the earth at presses more weight on the earth. Actually, the question is talking about the pressure. Okay, so if a man is sitting on a chair or on the ground, okay, suppose that man is sitting on the ground. Okay, man is standing on the ground, man is lying on the ground, none of these. You have been given 3 different positions, and in which one position the man will exert more pressure or highest pressure. Okay, so please give me, if suppose that I have already discussed that the pressure, the formula for pressure, this is equal to weight or force. Okay, force or weight upon contact area. Okay, force upon weight upon contact area. Okay, so here we can see that the pressure is inversely proportional to the contact area. Okay, pressure is inversely proportional to the contact area. If the contact area is low, very low, it means the pressure will be high. It means if the contact area is minimum, then the pressure exerted by the same man will be maximum. Okay, so first of all, add the option number A. Option number A, suppose that this man is sitting like this. Okay, this man is sitting like this. So okay, and this is option A. Okay, this man is sitting like this, like this, and the second option is standing position. Man is standing like this, and C option is man is lying on the earth. Okay, man is lying on the earth. Okay, so this is earth and none of these. So if we see that if the man is lying on the ground, then obviously the more contact area will be in touch with the ground. Okay, so more surface area of the body will be in touch with the ground. It means here the contact area is maximum. So if the contact area is maximum, it means the pressure exerted by this body will be minimum. Okay, so the pressure exerted by this body will be minimum. Okay, in case the contact area of this man with the ground will be minimum in the option B, because the area of the feet of this man is very low. Okay, that's why if the area of the man with the ground will be very low, it means the pressure exerted by this man will be maximum. So but in case of sitting, the area of this portion will be in contact with the ground. Okay, so area of the back side will be with the ground, will be in touch with the ground. That's why the maximum area will be in contact in C position, and the second highest area will be in contact in A position, and the third position means B position, the contact area between man and ground will be minimum, and hence the pressure exerted by the man on the ground will be maximum in this position. ठीक है ना? Am I right? So this is maximum pressure. Maximum pressure. Okay, maximum pressure. So this is this. What? This is this. It means B option will be the correct answer. B option will be the correct answer. Okay. So guys, please do like this session and comment in the comment box, and if you are watching this video and if you have any query, or you want to give the answer, you want to respond the questions, then please don't hesitate to answer them. Okay, whether it is right or wrong. If it is right, then your confidence will be boosted up. But if your answer is wrong, then obviously you will learn that what is the correct answer at least. Okay, so don't hesitate to answer in the comment box. Please do comment and ask your questions. If you have any query, I will answer them. Okay, so this was the first question. Okay, question number Question number two, if electrical conductivity increases with the increase of temperature of a substance, then it is a. Guys, we have learned in the electricity chapter, that if we increase the temperature of metallic conductors, the atoms of the metal starts vibrating at their own place like this. Okay, that's why these vibrating atoms create the hindrance to the flow of electrons, and hence the electric resistance increases. And hence we can say that if the temperature of the metallic conductor is increased, the electrical resistance of the metallic conductor increases. Here in this question, it is telling that the conductivity increases. In it means the resistivity decreases. It also means resistivity decreases. If resistivity decreases, it means this is not the conductor within, because in metallic conductors, if we increase the temperature, then the resistivity increases. But here this is talking that resistivity decreases. It happens only in case of what? It happens only in case of semiconductors, guys. Okay, so this is not the correct answer, and this one is also not the correct answer. Semiconductor is the correct answer. What is the semiconductor? Guys, there are three types of electric materials. Number 1, conductor. Number 2, insulator. Number 3, semiconductors. Conductors are commonly called those materials in which the electric charge flows. Okay, electric current flows, just like the metallic wires. All electrical wires in our homes, they are actually electrical conductors. Okay, salted water is a very good conductor of electricity. I think you guys have already seen a picture clip in a Bollywood movie that salted water is a very good conductor of electricity. You can watch this in Amir Khan's movie that was released in 2011, I think. 11 years or 3 idiots. Okay. So conductor. So these are the conductor materials. Okay. These conduct electricity. But those materials who does not conduct electricity are known as the insulators. Okay. Just like plastic, just like pure water. Okay. Just like PVC means polyvinyl chloride. Okay. PVC. You can see the electrical conductors, electrical wires in our homes. The plastic portion of the electric wire, that is actually made of PVC. PVC means polyvinyl chloride. Sometimes the name of this material is also asked. This is polyvinyl chloride. Polyvinyl chloride. Okay, so this is polyvinyl chloride. Okay, so this is insulator, and the glass means kaach, and bakelite. What is bakelite? Bakelite, actually this is a thermosetting plastic. Okay, bakelite is used to bakelite is used to manufacture the socket and electrical switches which are used in our home. Okay, so these are the materials which does not conduct the electricity, as well as the pure water. Pure water is also an insulator of electricity. Pure water, SF6 gas, and dry wood. But always remember that a wet wood is a good conductor of electricity. Wet wood is a good conductor of electricity, but a dry wood is an insulator of electricity. If you touch the electric wire with a dry wood, okay, you will not feel any electric shock. But if you touch the electric wire with the wet wooden piece, then obviously the electric current will conduct through the wooden piece, and you will get some electric shock. That's why always remember this thing and be careful about this. Okay. So this is the second thing. And the semiconductors, if we talk about the semiconductors actually, the conductivity of insulators is very, very low. Conductivity of insulators is very, very low. It means we can say that insulators does not conduct electricity. Okay. But in case of conductors, the electric conductivity is very, very high. We can say that the maximum value of electric charges flow through the conductors. Okay, but a material whose conductivity is less than conductors but greater than insulators, and these kind of materials are known as the semiconductors. Semi means half. Okay, in between. Conductivity of semiconductor material is less than conductors but greater than insulators, and hence these are known as the semiconductors. Semiconductor materials natural. There are two types of semiconductor materials. Number one, silicon and germanium. Silicon and germanium, these are two materials, these are two semiconductors. Okay, these are natural semiconductor. Okay, these are natural semiconductor. But when we talk about the N type and P type, N-type and P-type semiconductors. N-type and P-type semiconductors. Okay, so these are man-made semiconductors. Okay, so these are man-made semiconductors. Okay. So there are two types of semiconductors. I have already explained that one is natural semiconductor and another is man-made semiconductors. So silicon and germanium and N-type and P-type. Okay, semiconductor materials are used in all electronic devices. Semiconductor materials are used in all electronic devices, just like LED lights, diode, in all electronic circuits. Whether this is camera, whether this is television, whether this is mobile phone, whether this is computer screen, whether this is CPU, all IC chips are made of semiconductors. Nowadays, the semiconductor is being used in various electronic applications in automobiles also. Nowadays, the cars are made of the electronic circuits. They use the electronic circuits to improve their technology. Okay. Nowadays, you can see that the cars are driverless. Okay, Tesla has already developed a car which can be driven without any driving person. Okay, it means electronic circuits are being used in the car. If the electronic circuits are being used in the car, then obviously you can say that silicon or germanium has been used in this car. Okay, so this is the main reason. You can one thing I would like to tell you that nowadays you can watch on the news that China has attacked on Taiwan, and American fighter planes are also visiting China and Taiwan again and again, just to stop the bar between China and Taiwan, because China wants to take over the Taiwan, just because Taiwan is a very good source of semiconductors, a very large producer of semiconductors. So most of the electronic items come from the Taiwan. You can see your mobile phone also. If you are using Apple, then obviously Apple or any other mobile phone, either this is Apple or Samsung or any Chinese phone or any electronic item, whether it is Japanese company or Indian company or any other company, the semiconductor portion has been imported from the Taiwan, whether it is by the way of China or direct from Taiwan. Okay, either this is Philips or any company, all the companies are using the semiconductors produced by the Taiwan. Okay, so this is the main reason of the contract. The conflict between China and Taiwan. Okay. So this is the property of the semiconductor. Okay. So I think that you will remember all these points, that if we increase the temperature of the semiconductor, then the conductivity increases. Okay. Product of force and velocity. This is a very good question. Product of force and velocity. This is known as product of force and velocity. Guys, force and velocity. First of all, we should know about the velocity. Velocity is equal to, velocity can be written as displacement upon time. Okay, so force into velocity, and this is equal to force into displacement upon time. Okay, so now guys, you can see that force into displacement, this is known as work. Upon time. Okay, this is work upon time. This is known as power. Okay, This is known as power. So guys, here you can see that which one option is correct, and here we can see that the power option B power is the correct answer. Okay, Suresh, no, sorry, this is not the momentum. Mass and the velocity is called the momentum, but the force and velocity, this is known as the power. Now I think you have got it. Yes. B for Bombay. B for Bombay. Okay, please do like this session and share among all your friends. Okay, so I think you guys have got it. Okay, now we will move to another question. Which one of the following has the highest value of specific heat? Guys, what does it mean by specific heat? Actually, specific heat, do you know the definition of specific heat? First of all, you should know about the specific heat. What is the specific heat? If you know it, then please tell me. If you don't know, then please tell me that you don't know, and you want to learn. Okay, then I will tell you the definition of specific heat, and then I will tell you that which material has the highest specific heat among all these four materials. So please tell me whether do you know the specific heat, what is specific heat or not. Yes, tell me. Please write down your name and the district name. Where are you actually watching from? Tell me. You guys are very silent and don't comment during live session. Specific heat. Specific heat is the heat required to raise the temperature of 1 kilogram material by 1 degree Celsius. Suppose that a material has been filled. A material has been filled in this box. Okay, so this is a cubical box, and 1 kilogram material has been filled in this box. Okay, now you have to raise the temperature of this material by 1 degree Celsius. So you will need some amount of heat. If you will need some amount of heat, and that amount of heat will be known as the specific heat. Okay, here if we talk about the specific heat of alcohol, it means 1 kg alcohol, 1 kg alcohol. Okay, 1 kg alcohol, temperature of 1 kg alcohol has to be raised by 1 degree Celsius. Okay, so methane, 1 kilogram methane gas, the temperature has to be raised by 1 degree Celsius. Kerosene, water. Okay, so there are four materials given. Okay, you have been given the four materials: alcohol, methane, kerosene, water, and you are requested to take the sample 1 kilogram and raise the temperature of 1 kilogram by 1 degree Celsius. Okay, then which material will require the more heat? Obviously, if you want to increase the temperature of 1 kilogram by 1 degree Celsius, the water will need the highest or maximum amount of heat. Water will need the maximum amount of heat to reach the temperature by 1 degree Celsius. Okay. Andhra Pradesh, Hyderabad. Okay, that's great. Very good. Are you getting all these points? Are you getting all these points? Okay. Actually, these are the experimental facts. These are the experimental facts. Actually, water has the very high specific heat. Those materials who have the high specific heat can store the heat energy till the large span of time. Okay, the storing heat storage capacity is very high of the materials who have very high specific heat. Okay, these materials take a large time, long time to just raise the temperature, but these materials take the long time to just cool down also. Okay, so these materials can store the heat till the long time. Okay, and this is the reason that water is used in various applications in our daily life. Just suppose that when there are the patients in any private ward or any regular ward, okay, in the hospitals, and they don't get any heat from the outside, so that they can feel better actually. So the doctors suggest the patients to heat their body with the help of the warm water. Okay, warm water. A warm water. A water sample of 1 liter or half liter is heated up to increase, heated up and then filled into a rubber packet. Okay, then this rubber packet is closed by the lid, and then this rubber packet is actually touched with the body of the patient, and the patient get the heat for the long time from that packet. Okay, because the heat storage capacity of the water is very high. Water can store the heat for the long time because water has the highest specific heat. It means the maximum specific heat. Okay, there are some other materials also who can store the heat for the long time, but water is the very cheap and very easily available material which can store the heat for the long time. Okay, so this is the reason that water is used by the patients to heat, to provide the heat to the patient's body. Okay, the another application of the water is that water is used as a coolant in the car or truck or public buses. Actually, water is used as coolant. Coolant means which can maintain the temperature of the engine at low level, because we all know that the water has very high specific heat. Water has very high specific heat. Those materials who has the high specific heat get heated or takes the long time to raise the temperature. Okay, so if we fill the water in the tank connected to the engine, the water will take the long time. Water will take the long time to raise its temperature because it can store the huge amount of energy, and it just shows the very less temperature increase. And this is the reason, that water can accommodate a large amount of heat into it. It will indicate a very less temperature increase. Okay, so this is the reason that water is used as a coolant, because it will get heated after a long time. If the water will get heated after a very long time, then obviously it will remain cool for a long time. If this water will remain cool for the long time, then obviously the engine will also remain cool for the long time, and in this way it will keep the engine cool. Okay, so that the engine can perform better and an engine will not be failed. Okay, so this is the reason that water is used as a coolant, because this is a natural coolant and available everywhere on the nearby road or anywhere it can easily available. Yeah, low specific heat, just like sand. Those materials who have the low specific heat can the temperature of these materials can be increased very quickly. But those materials who get heated very quickly, those materials also lose their heat very quickly also. Okay, so these materials come cool down very quickly also. Okay, just like sand can be heated up very quickly, but sand can be cooled down very quickly also. So, okay, so those materials whose specific heat is low gain heat very quickly and lose heat very quickly. Okay, so, and this is the reason that in desert areas, during daytime, the temperature of the surrounding atmosphere as well as the temperature of the sand becomes very high within a short span of time after rising of sun. But as the sun sets in the evening, the temperature of the surrounding atmosphere and the sand goes down very quickly. Okay, so this is the reason behind that, because sand possesses a low specific heat value. Okay, so this is the reason. Since the water has the high specific heat, you can observe that the atmospheric temperature of coastal areas is approximately constant during day and night. Okay, you can observe that the atmospheric temperature near the coastal areas is approximately constant during day and night. The reason behind is during daytime the ocean water receives the heat from the sunlight and it stores a huge amount of heat and just raises a very low amount of temperature. Okay, but the whole ocean receives the huge amount of sunlight, huge amount of solar energy, solar heat from the sun. Okay, and it stores, but during night when the sun sets off, this heat this heat is radiated by the ocean water to the coastal areas, and during this period, during night, the heat is radiated by the ocean to the coastal area, and this is the reason behind that the temperature at the coastal areas is approximately constant during day and night. Okay, till morning the heat from water to plain area or water to land area, radiation stops because the sun, obviously sun, when the sun rises, water again it starts accepting heat from the sun, and it means it starts receiving heat from the sun, and the temperature of the water starts increasing. But the temperature of the water does not rise too much insignificant number, because the amount of the water is very high in the ocean. That's why the heat received from the sunlight is not too much, so that it can just boil the temperature, boil the whole water of the ocean. Okay, so that's why it raises the temperature of the water in a very little amount. Okay, but the amount of heat stored by the ocean water is very high. Okay, because the amount of the water is very high, and this is the reason. Okay, got it or not? Suresh, have you got this point or not? Is there any confusion? Then please tell me. You can, and I will try to resolve all your doubts. Yes, Monica. Any confusion? Any problem? Any confusion? Any problem? Okay. So again, with the increase of the pressure, the boiling point of any substance. This is a very good question actually. There are 3 or 4 questions which are based upon this concept actually. When we talk about the atmospheric pressure and boiling point, let me explain what is the boiling point. Suppose that this is a pot. This is a metallic pot, and the water has been filled in this pot. Okay, water has been filled in this pot like this. Water has been filled in this pot like this, is like this. Okay, so, and this is a heater. This is a heater. This is a heater. Okay, we start heating this water. After some time we see that water starts evaporating. Water molecules starts converting into the gaseous state. Water molecules starts converting into the gaseous state. Okay, so this is the gas now. So this is the gas. Okay, the upper portion of the water is now a gas, and this gas possesses some pressure. Okay, so this gas possesses some pressure. So guys, here you can say that this gas has some pressure, certain pressure, like the value of pressure is P. Okay, like the value of pressure is P, suppose that, and this is the pressure. The direction of this pressure is in is random. Okay, any direction, all possible directions. Okay, so this pressure can be shown in this direction, in this direction, in this direction, in this direction, everywhere. Okay, everywhere. But I have mentioned this pressure in vertical direction just to explain the concept. Okay, just to explain the concept. So guys, so this is the pressure. Okay, suppose that this is the pressure. Now we all know that atmospheric pressure also exists. We all know that atmospheric pressure also exists. Suppose that atmospheric pressure, obviously an atom, a gas molecule exert pressure on nearby surrounding bodies in all the directions. Okay, so but when we talk about the atmospheric pressure, I have just taken one direction of the pressure, which is just opposite to the direction of the pressure of this water gas. Okay, so this is the atmospheric pressure, this is the atmospheric pressure. Okay, let me write that P atm, this is P atm, this is P atm, and this is P vapor. Okay, this is vapor pressure. So this is vapor pressure and this is atmospheric pressure. This is vapor pressure and this is atmospheric pressure. Okay, when we heat the water, and this vapor, if the pressure of this vapor becomes equal to the atmospheric pressure, the instant at which the vapor pressure becomes equal to the atmospheric pressure, the temperature at which this happens is known as the boiling point. Water starts boiling. Water starts boiling when the vapor pressure of the liquid becomes equal to the atmospheric pressure. Liquid starts boiling, and that temperature is known as the boiling point. And suppose that we have increased the atmospheric pressure. Now to boil this liquid, what we will have to do, we have to increase the temperature of this water so that the vapor pressure of the liquid of vapor pressure of this water, vapor pressure of this liquid can have the higher value to equalize the atmospheric pressure so that the water starts boiling. Okay, now so we will have to increase the temperature of this water so that at high temperature the vapor pressure will also be high, and after some time the vapor pressure value will be equal to the atmospheric pressure, and at that temperature this water will starts boiling. And it means, hence we can say that if we increase atmospheric pressure, then we will have to increase the temperature of the water also so that it can starts boiling. It means the boiling point increases. Okay, so if we increase the atmospheric pressure, the boiling point also increases. So this is the concept behind. If we decrease the atmospheric pressure, then obviously the boiling point of the substance also decreases. Okay, so here with the increase of pressure, the boiling point of the substance increases. So A will be the correct answer. Suresh and Monica, you are wrong. Suresh and Monica, have you got it? What I wanted to explain actually? Have you got it? Have you got the concept behind this question? I have explained the concept behind this question. Is the concept clear? Please tell me. Is the concept clear? Please do like this session and share among all your friends. Okay, Suresh, great. Monica, is this concept clear to you? Okay, so now next question: if no external force acts on a system of bodies, the total linear momentum of the system of bodies remains constant. Which law states that? No external force. No external force. In the afternoon session, I have already taught the laws of motion. In those chapters, in those videos, you can watch that I have already told this case in my video lecture. Okay, so if no external force acts on the system of bodies, it means body. If no external force acts on the body, then the total linear momentum of the system remains constant. This is known as the law of principle of conservation of linear momentum. Principle of conservation of linear momentum. Okay. See, actually, the D option will be the correct answer. D option will be the correct answer. Okay, so D option is the correct answer. This is actually the law of conservation of linear momentum. Okay, we all know that I have already explained that delta P upon delta T. This is F is equal to delta P upon delta T, and this is known as the rate of change of linear momentum. If this force is zero, it means delta P upon delta T is equal to 0. It means delta P will be equal to 0. Delta P means P2 minus P1. P2 minus P1 is equal to 0. It means P2 is equal to P1. It means P final is equal to P initial. It means the final linear momentum of the body is equal to the initial linear momentum of the body. It means the linear momentum has not been changed. It means the linear momentum of the body is constant. It means if we do not apply any force on the moving body, then the linear momentum of the body remains conserved, and this is known as the law of conservation of linear momentum. Okay. Now, next question. Which law is also called the law of inertia? I have already told you that law of inertia is known as. Please tell me, this is a very simple question and you all can answer it. You all can answer it. Yes, tell me, which law is also called the law of inertia? Newton's first law, Newton's second law, Newton's third law, or all of these? Please tell me, which one is the correct answer? Which one is the correct answer? Yes, tell me. Which one is the correct answer? Which one is the correct answer? Which one is the correct answer? Yes. No. Newton's first law is known as the law of inertia. Please do watch the lectures I have already taken in 2 p.m. session. Okay. First law of motion is known as the law of inertia. Law of inertia was given by the Galileo. Law of inertia was given by Galileo. But the laws of motion, laws of motion were given by Sir Isaac Newton. Sir Isaac Newton. Okay. Laws of motion were given by Sir Isaac Newton. Okay. So remember the names of these scientists too. Guys, please note down these questions as these are very important questions. Okay. Now the next question, what is the unit of astronomical distance? Astronomical distance, it means that this distance is used to measure the distance between the two planets or any two galaxies. Actually, when we talk about the astronomical distance, angstrom is a very, very small. Weber, this is a magnetic unit. Lux, this is a light unit. But the light year, actually you see that light year is appearing just like that unit of time period. It means the time, but this is not the actually unit of time. Light year is the unit of astronomical distance, because one light year means the distance traveled by the light in 1 year. You know, the speed of light is, the speed of light is 3 into 10 to the power 3 into 10 to the power 8 meters per second. And this is the distance traveled in 1 second. In 1 hour, there are 3600 seconds. And there are 24 hours in a day. There are 24 hours in a day. And there are 30 days in a month. And there are 12 months in a year. So this is the total distance traveled by the light in 1 year. Okay, this is the total distance traveled by the light in 1 year. So this is a very, very long distance, even you cannot walk. Okay, so here the A part will be the correct answer. A part will be the correct answer. Okay. Energy possessed by a body in motion is called. When a body is in motion, then obviously the energy the body have is known as the kinetic energy. Kinetic energy is the correct answer. Kinetic energy is the energy contained by a body in motion, during motion. Okay, so kinetic energy will be the correct answer. The electric motor converts electrical energy into mechanical energy. Electrical energy into mechanical energy. Electrical energy into mechanical energy. Okay. Electrical energy into mechanical energy. Mechanical energy, yes. So this is the correct answer. But when we talk about the mechanical energy into electrical energy, actually this is the generator or alternator. Alternator which generates electricity. Okay, that mechanical energy converted into electrical energy. Okay, so here, but when we talk about the electric motor, we supply the electrical energy to the motor starts moving, and then we get the mechanical energy. Okay, what is the scale used for the measuring of intensity of the earthquake? When you when you watch the news, then you have already heard about the Richter scale. Actually, Richter scale, and this is the unit of the earthquake intensity of the earthquake. That the Richter scale of 6 is very, very dangerous. Okay, so this is the Richter scale actually. A jet engine works on the principle of conservation of linear momentum. So here this is the correct answer. Please do watch the lectures I have already taken in 2 p.m. session. I have already explained all these things. Okay, so please, if you have not watched these lectures till now, then please do watch these lectures, and I'm sure that you will get all the doubts cleared there, because I have already explained with the very basic. Okay, so here the correct answer is linear momentum. So this is over for the day, and tomorrow I will also at 10 p.m. tomorrow I will come online and will teach you some more questions. I will come, and please do like this session if you have not liked till now, and subscribe this channel for the continuous updates from our side, and do watch all the lectures. Rest of the teachers are waiting for you. Thank you so much. Have a nice day. Bye bye.